Is this one on? Yep. Okay. Good morning, everyone. Thank you to CAASTRO for having me today. I'm really excited to be speaking to the... I'm good with this one. Thank you. Next generation of people going into this, entrepreneur world and next generation of influencers, essentially. So I guess in the next 10 minutes, I'm going to tell you about STEM and why it's really important, I think, and how it's been pivotal for me to make a difference in the world and what I've learnt along the way in my sort of short-lived career to date. So I'm here because I once treated my hair with olive oil. Yep, stuff you dip your bread in, olive oil. This is what changed my life, really. It was an experiment that I carried out and was able to establish that breast cancer could be detected in blood, and it was how my career started. It led me to make a discovery that gave rise to BCAL Diagnostics, which is the company I work for today, and I'm now chief scientist of that company, and I get to make a difference, and it's really exciting, and it's what gets me out of bed every single day. So I was able to do this because I embarked on a career in STEM. So ask yourself, how many other occupations are out there that really allow you to make a radical change in the world, really make an impact and make a difference? So for me, taking my scientific research out of a lab and bringing it to life has been really motivating and has given me the power to, have more confidence and belief in myself too along the way. So it's been a really steep learning curve. How did I get here? Well, like Michelle, I have a really keen sense of curiosity and inquisitiveness, and I do like to know how things work and problem solving and all those sorts of things. So as part of my HSC, I did include biology and mathematics into my subjects, along with business and IT and things like that. But did I know what I wanted to do? No, not really in Year 12. I sort of came out of Year 12 and thought, okay, well, I like science. That's my favourite so far, and I'm pretty good at it, so I'm going to go with that. The thing with science is there are so many different streams, so I wasn't really sure what I was going to end up doing, but I didn't know I was going to be a scientific researcher, nor did I know I was going to be in cancer, for that matter. I just knew that I loved it and I wanted to do something that could help people. So in the end, I enrolled at this very university, Sydney University, and I did a Bachelor of Science with honours, majoring in microbiology, which is the study of bacteria, fungi and viruses. And I basically finished uni and thought, okay, I really want to get a job, make some money and travel the world. That's literally what I came out doing. But I got a gig. My first job was with a company that was actually looking at the association between breast cancer and scalp hair. And this is where I made that big olive oil discovery. And I think for me, I took some initiative there and sort of the idea and the theory behind what they were doing was really interesting. But then I took an extra initiative to carry out experiments while I was there to come up with this discovery, and that was purely because the science was so interesting. It's like breast cancer and hair. How can you detect breast cancer using hair? And that's how we were able to establish that, if you've got a tumour here and your hair's here, something's floating around in the blood, and we were able to find markers that indicate the presence of the disease. So I had a mentor there who was my boss at the time, and, when we made that discovery together, actually, we put in a patent, so that's the IP, and we decided we'd form BCAL Diagnostics in 2010 to further carry out this research. And my mentor said, you should do a PhD, and I thought, I was a bit reluctant. I don't really want to do that. It wasn't really what I had in mind. But with the right encouragement, I thought, you know what, I think this is... that was the moment I turned into an entrepreneur, actually, because it was the moment that I said to myself, I helped birth this idea, and I want to be a part of its journey from here to wherever it ends up going, and whether it fails or succeeds, I want to be there along the way. And it really made me determined. So I decided to say yes and just have a go, and I carried out my PhD to further do this research, and it's the basis of BCAL today. So taking an innovative idea out of the lab and into the real world, it was really, a whole new ball game for me as a traditionally trained academic scientist. It's a really long road, and the discovery is actually the fun part. That's the part where you're like, yeah, this is awesome, it's going to do something, I think, and you believe in it and all that sort of stuff. But then you see the roadmap ahead, and you kind of go, oh, okay, wow, I didn't know this had to happen. So as a blood test, it's unlike anything that's on the market at the moment. Right now, the gold standard in this area is mammograms for women over the age of 50. And for women younger than 50, it's actually the hand, which is really not good enough. So hence why I'm doing what I'm doing. So this means my technology really has to prove itself to both the medical community and also involves years of research and studies. So 2010, it's already been 7 years, and after you do that initial discovery, you have to show that you can repeat it, you have to show that you can validate it, you have to show that it can be independently validated through clinical trials. So it's all a really long journey, and it also eventually has to be approved by the federal regulators, which means that it has to have the lowest risk and the highest reproducibility and be able to be used for everyone. So what I'm trying to say is it is a lengthy process, and you really need to be self-motivated and determined and just keep on keeping on, really. You're not going to make money immediately and quickly. It's not one of those big, quick turnaround kind of companies. And we're still not there yet, honestly. You know, we've still got to go through clinical trials and get there. But the motivation is obviously the end goal, which is to impact lives. And I think that's what science is all about. It's the reason I got into science. It's the reason science exists, or STEM, I should say, not just science. It's any technology, engineering, mathematics. It all impacts the world. And it's an ecosystem. So if research is your game and you don't really want to jump ship and get into commercial world, industry still does need you. I need engineers, software developers, statisticians. For my one technology alone, I work with the entire STEM ecosystem. So there's always a role for everyone, and collaboration is crucial to making these sorts of technologies succeed. I guess my advice to you guys is to keep an open mind. I learned from taking a risk and taking a job and having a go. I had no idea what I was doing in the commercial world. I learnt through failure. Lots of people told me you're not supposed to do that, and okay, I won't do it next time. And that's exactly how I gained lots of traction and added value to my role, basically. So I used to take on small courses and internships with other companies, and it's just about multi-skilling yourself. So when you get out there, you've got the skills to do all sorts of things in a company. And I've learned to pitch, I've learned to write business plans, all the things that a scientist would not traditionally do. And then I also get to do all the scientific stuff, such as, you know, design experiments. So it's a wonderful variety. So I encourage people to multi-skill themselves. I guess what I think you need if you're going to do this and you're going to go for it is to find yourself a mentor. I think that's been absolutely important to my journey. And the one thing I can't stress the importance of enough is networking in different industries. So academia and industry, and door knocking and talking to people and asking what do they do and what are they looking for. They might be looking for you and they may not even know it. So solve problems, join societies, enroll in short courses, just take it all on. Yeah, and I think I'm still on that journey, and it's very rewarding. I think if you're a teacher or a parent in the room, nurture the flame. If you see someone that's, you know, doing really well in this area, help, because support and mentorship have been absolutely crucial to everything that I've done. And my final advice is, I think it was in the brochure, but don't let your self-confidence stop you from doing anything. If something's offered to you, just say yes, take it, fail at it, it's totally cool, and just keep on going. Don't be afraid of failing, because it's actually the best way. Those scars will be the best that you have. So yeah, go for it, iterate and keep going, keep learning. Yeah, thank you.
Right, do we have questions for Dharmica? Did you guys not have enough sugar this morning? No, the hands are coming up, good. Yes, got to warm up.
Okay, so you said that they found breast cancer signs in hair follicle, scalp hair. How did they do that?
How do they do that? They used to use a really big X-ray, I guess you could call it, big particle accelerator. So it's called a synchrotron. There's one in Melbourne. And basically when you X-rayed the hair, the picture, because you get a picture when you X-ray hair, from the diffraction of the light around the hair, there was a feature coming up that indicated that you had breast cancer, and it was coming up about 70% of the time. So there was a normal hair a normal person's hair, and then a person who had breast cancer, and there was this difference. And that's where it started, and that was just a physical phenomena, but not a biological one. So they didn't know why it was happening, but they knew it was happening. And that's where the discovery that I helped with was was able to establish why that was happening.
How much longer do you think it'll take to bring this process to market?
Every year I say another year. No, it's like, I think, look, it's realistically, there are lots of different things along the way, such as you've got to raise funds and whatnot, and there's always, you can't predict data in science, and that's a part of the individual variability of what you're doing. So therefore, for me, I hope, and ambitiously I hope, another year or two, we've got all the right tools and things in place, but it all depends on funding and the data, basically.
Thanks for your talk, because I think I'm from a chemistry sort of background, and a lot of the talks we've seen about like software sort of products, and from a perspective that you've just given, that you actually can take a long time to get a product to market. So, are you is this business paying, like, is this your income now, or are you still working with the other company?
No, it's a really weird story, but that initial company that I was working for, that was X-Ray, they actually went into bankruptcy, like administration, and I lost the ability to do my PhD, and it was a really tough period, but that's why BCAL was formed. We actually purchased the IP. It was a really ugly period, but that was the formation. So I've always been, full-time at BCAL since 2010.
And just really quickly, did you say there was 2 tests for breast cancer? One was for the hand, for people under 50?
Yes.
Right?
So for women under the age, we're not eligible for a mammogram. It's not as, they just don't recommend it, and there's lots of reasons why, and I won't go into them. But so we go for clinical physical examination of the breast, or you should be checking yourselves, young ladies. But yeah, it's still not good enough, because by this time it could have it progress quite a lot. So, yep, something earlier and more accurate is what we're after.
And having your breasts squashed between some plates, is not pleasant.
Exactly.
Not that I've done it, because I'm not over 50 yet, but I've had elderly relatives speak of it, and I can't say that it sounds attractive for when I get older.
Well, I have been through it on behalf of the patients to see what my customers are going through, and it is tough.
I see this as a quick learning opportunity. As a teacher, I'm always looking for them. I presume you're using a lot of statistics in your ability to detect the difference between blood with cancer and blood without. Can you just tell the girls a little bit about that? Because I think a lot of people don't realise that in biology and medicine, statistics is a huge field, and even coding with statistics is a huge field.
Absolutely. So I really discounted that when I was young too, and I did early stats and sort of forgot about my stats once I'd done it in first year uni. But when you get to a point where you're trying to prove up something and you've got different groups of people that you need to prove it up for, the stats is everything. So you need to understand, for example, the first thing a medical practitioner will want to know about me is how accurate is your test? And if I say something like 90%, it then goes back to the statistics of understanding how many people did you pick it up with that didn't have the disease, that did have it and didn't have it, and it's all very important. So it is absolutely crucial to basic scientific research, discovery, and any commercial science as well. Absolutely. You're going to need it, and you will get thrown that card.
Right. Could everyone please thank Dharmica?
Thank you.